All right, today we are practicing solving quadratics by completing the square. It's all about practicing from yesterday. So problem number 1, solve x squared plus 12x plus 4 equals 0. Guys, okay, so what do we do? Wait, hold on, time out. Before we talk about what to do, I want to let you know that I'm not going to write out all the steps for today like I did yesterday, because what I want to illustrate to you is I want to provide a good example for what your work should look like on your quiz on Friday. You know, how would I show my work? What's your showing your work? So what do we do? What's step 1? Billy? Excellent. Yeah, you minus the constant, so we subtract 4 from each side. Excellent. That's pretty sweet, right? So now we get x squared plus 12x. Now I'm gonna leave a space right there because everybody knows what step 2 is, right? What do we have to add to each side? We have to add b divided by 2 squared. What's b in this particular case? What's b divided by 2? B divided by 2 is 6, and what's 6 squared? Very nice. So we need to add 36, b divided by 2 squared, to each side. And then we get this. Just let me know if you get lost along the way. Equals 32. And what's the next step in the process? No way we don't subtract 36. What do we do, Henry? Starts with an F. Crystal? Yes, we do. Crystal, how does this factor into being? What does it factor into? What are you thinking? I'm not sure. What do you think? Come on, Crystal. You can do it, girl. I believe in you. I feel it coming to you. I can see it. Come on now. Come on, Sophia. Yeah, it's x plus 6 squared. Very nice. Yeah. And so at this point, we're going to take a stop. We're going to take a little break. We're going to take a little break, and we're going to talk about this. Does anybody not understand where any of these come from? Christine? Sure. Let's recap for a minute, right? When we got to this step, this written in green, this 36 right here is b, right? That's b, 12. B divided by 2 squared. We have to add that to each side. So b divided by 2, 12 divided by 2 is what, Christine? And 6 squared is what? So that's why we have to add it to both sides. And then that's where we got the rest. And now this is called a perfect square trinomial because it breaks up into x plus 6 times x plus 6. And you just write that down like this. And then we keep going. And what's the next step in the process? We square root both sides. You get x plus 6 equals plus or minus the square root of 32. And then what else? Is this getting really annoying? Not yet. You have to leave it like that. What's next? Any ideas for what we should do next? Really? We have to make x by itself. We have to. Whoa there, Henri. Whoa there, Henri. You have to do this. And then technically, right, if you get to this stage right here, you get 3 of the 4 points. But we're going to bring it back old school style. Rewind. Because you have to simplify this radical. Oh, no. Ow. Simplify the radical. So once again, let me remind you that if you got all the way to here, right? If you got all the way to here, let me erase this red X. You get 3 of the 4 points, and you did an amazing, fantastic job, and you should consider that success. But to get the 4th and final point, right? The 7th Dragon Ball, if you will. Okay. Then this has to break up. Give me 2 numbers that multiply to be 32. 16 and 2, because one of them has to be a perfect square. Do you remember this? 8? Oh, you're right. And so this final answer, final ridiculous answer, that's the answer to the question. We had a great question just asked saying that, like, okay, so like at the end of the day, right? At the end of the day, when you do this problem, aren't you supposed to get the roots? That is the roots. The roots. The roots. The roots. The roots of this equation are... Wow. Come on, man. You guys got to get amped up. I love this stuff. -6 plus 4 radical 2. And what's the other root? If you want to represent it like that, that's fine. I'm down with that as well. Problem number 2. How is problem number 2 different than problem number 1? Yeah, the constant is already on its correct side. We can just proceed with the next step. So can somebody tell me, what is it I'm going to add to each side? Selena? Yeah, we're going to be adding 4 to each side because positive 4 divided by 2 is 2, and 2 squared is 4. So we're going to add 4 to each side. X squared plus 4x plus 4 equals 25. All right, now we got to do our thing. Can somebody factor that left side for me? You already have the answer. Yeah, it is that is the answer to it. You're better. You're amazing. But let's go and let's not skip directly to the answer. Let's go with can somebody factor that for me? Selena? Very nice. Yeah, it's going to be x plus 2 squared equals 25. Okay. All right. And then what do you do after this step? You know it. You go, girl. Let's choose a different one. Right? And then we subtract 2 from each side. And we get x equals -2 plus or minus the square. Oh, what's the square root of 25? Oh, so you know this, so I can put 5 here? No? Yes? Because these two are the same thing. I'll put a big arrow there. Okay? And so finally we get this. What's the final answer to this problem? X is equal to -2 plus 5. And so that's the same thing as 3. And x equals -2 minus 5. And so that's -7. Final answer. Yeah, piece of cake? Guys, problem number 3 is pretty much the hardest completing the square gets to, and that's because there is a really important restriction that you have to remember. Got to remember this. So completing the square works with only 1x squared. And so you're given a problem up there where you're given 3 of them. What can you do, Cameron? Divide everything through by 3, and then it goes back to a normal problem. So remember this. Remember this. Remember this day of December when we talked about the rules of completing the square. So we got to divide everything through by 3, and then check it out. We get 1x squared. Ooh, just what we needed. Equals -4x minus uno. What do we do next? Does anybody else want to come up here and finish the problem? Oh, okay. Everybody in the other class was like, yeah, let me do it. I want to come up here. It was like a fight. Watch this. What happens if I offer bonus points? See, look at this. Now I get everybody's hand raising. Okay, I see how it is. You guys are just tired, huh? All right, here we go. So we got to add 4x to each side, right? Because we got to get numbers by themselves. We got to get constants by themselves, and everything else over to the other side. And then, ooh, I messed that one up because I told you we always have to leave a space when we're completing the square. Now, what are we going to add to each side? Yeah, we're going to add 4 to each side because 4 divided by 2, b divided by 2 is 2, and 2 squared is 4. Add that to both sides. This, when we factor it, becomes x plus 2 squared, right? because it's a perfect square trinomial. Uh-huh. And then what do we do? And then what do we do next, Hill? Come on, Hill. Tell me what's up. Come on, Hill. We got to square it. Square it up. You know what this is, right? What do we do next? Oh, yeah. We're on a roll. Be subtracting 2 from each side. Booyah. What now? What now, problem? What now? You thought you had us, but you didn't. You thought so, but you got stopped. Hold on. Problem number 4, rounding out the day. We have 4x squared minus 8x plus 1 equals 0. First, we got it. It doesn't now see. It doesn't really matter if we subtract 1 over or if you divide by 4. That doesn't make a difference as long as you know just the steps you have to take to solve it. So, what do you want to do first? Let's move this 1 over. Okay. So then we get 4x squared minus 8x equals -1. Then what do we do next? Got to divide everything through by 4, right? Because the rule states you can only do completing the square when you got 1x squared. Minus 2x equals, do you want this to be -1/4? Or do you want it to be a decimal? I'm going to tell you it doesn't really make a difference. Whichever makes your life a decimal?
No.
That's okay. Let's do this. Let's do this. I appreciate that. I'm going to show you what will happen in the end. Ah, chill, yo. Don't worry. It's a good experience to go through. Okay, so now we have to complete the square. Let's divide b by 2 squared and add it to both sides. What are we adding to both sides then? Going to be adding 1 to both sides because -2 divided by 2 is -1, and -1 squared is 1. Plus 1, whoops. And then we have the following, right? This side condenses down to being, let me write this down, and then we'll shorten it. Because otherwise people are going to get confused. This, if I owed somebody a quarter, but I had $1 in my pocket, I'd be up 75 cents. Ooh, a lot of money. Might go get some Sun Chips with that, right? Love Sun Chips. Oh, it's messed up. Okay, Sun Chips are 85 cents. Okay, guys, help me factor. Woo, you guys are amazing at factoring. Look at you. Where'd you learn that? Who was your last year teacher? Miss Russell was amazing factor. Mr. Ritako also amazing factor. What do we do next? Square root equals plus or minus the square root of 0.75. And then we're going to be adding 1 to each side. This cancels off. We get x equals 1 plus or minus the square root of 0.75. And here's the interesting point. Here's the interesting problem that we're going to face, right? Remember that first problem that we did? Remember how we had to reduce the radical underneath? When you have things represented by a decimal, you genuinely don't know if it's been reduced all the way or not. So convert this back into a fraction. Okay? Oh, I know. Don't worry, it's not as bad as you think it is. Oh, no. Okay? So convert it back into a fraction. You know what? We don't need our calculator for something like that. This is too easy. Yeah. X equals 1 plus or minus the square root of 3 over 4. Now, when we were doing square roots, right, I told you that this thing right here would break up into being, this radical would break up into 2 small radicals. Remember this from back in the day? Chill, yo. We don't need to multiply by anything because the bottom reduces. If it didn't reduce, we'd be screwed, but it does, so we're good to go. And that's the end of the problem. And we did great work for today.